Hello, it's Dr. Bhatt presenting this a number of slides on surface tension. Please go through the lines here. Finally, we find that learning with devoted concentration yields fruitful result. Therefore, it is requested that our students must watch it in full and learn as much as possible about the topic surface tension in liquids. Of course, the property surface tension is related to liquids, and we find that it is nothing but the jugglery of intermolecular forces that liquids exhibit, a peculiar property termed as surface tension. Means there is some type of tension at the top of the liquid, and because of this we find that there is a elastic membrane or elastic skin at the liquid surface. Now, what is that elastic skin and how it is formed? We are going to take up. What is surface tension? Liquids possess typical properties resulting out of intermolecular forces such as fluidity, viscosity, vaporization, evaporation, etc. And they do maintain their own liquid level. It is realized that at the liquid level, they resist an external force due to cohesive nature of the molecule. Now, what is this cohesive nature we are going to take up? Such a property is termed as surface tension. Now, there are two diagrams here. You find finally that attraction of the surface particles as compared to the bulk of the liquid strives to decrease the surface area. Here is a diagram. It represents a number as known to us. A number of molecules are present in the bulk of the liquid, which is stored in a beaker or maybe any other container. And then there are a number of particles at the surface also. Surface of the liquid, at the top of the liquid. And now what we find, we shall consider a molecule in the bulk of the liquid and also a single molecule at the top of the liquid. Now, a molecule which is at the bulk of the liquid is attracted by all around molecules around it. A number of molecules, they exert an attractive force to this. Right? And what about the molecules at a single molecule at the surface? We find that at the surface, the lower molecules just below it, the molecules underneath the surface, they attract a molecule which is at the surface of the liquid. And because of this attractive force, there is some type of pulling action on a particular molecule. And like that, there are several molecules at the surface which feel a pulling force, pulling downwards, as you find. Now, let us consider the attractive force, taking water as an example. At the surface of the liquid, a number of water molecules are there which are attracted by each other. And because of these attractions, they come closer. The distance between them is decreased. And gradually, what happens that a membrane type of film is created, which we call it as an elastic skin at the liquid surface. The surface molecules of the liquid are pulled by the inner molecules close to the surface. This pulling force results in the surface molecules to contract. There is another force acting tangentially over the surface of the molecule. What is tangential force acting over the surface of the molecule? We are going to take up a little later. This accounts that surface behaves as a stretched film or elastic membrane. elastic skin or elastic membrane, we can call it. This is an inherent property of the liquid dependent on its composition. So now, after understanding what is a tangential force, we can define what is surface tension in terms of certain units. Tangential force is the force that acts parallel to the surface of the liquid, parallel to the surface of the liquid at the interface between liquid and another material or medium. Because we know that liquids are always stored into another material. It is a container, a beaker, or maybe anything. And not only this, the liquids are exposed to the gaseous medium above it normally. It is also known as the tangential force is also termed as tangential component of the surface tension force. Surface tension is a force caused by a force, and its tangential part or tangential component is known as tangential force. It acts tangentially or even perpendicular to the normal direction of the surface. This resists any attempts to deform or stretch the liquid surface. So, after having a concept about tangential force, we can definitely define it. The surface tension of a liquid is defined as the tangential force acting over the surface of the liquid at right angles along one unit length drawn on the surface of the liquid. It is given per unit length, force acting per unit length, and therefore it should have certain units. Now let us see how can uh, we get it. There is another concentration. Surface tension is also considered as a force acting per unit length on an imaginary line drawn on the liquid surface, tending to pull the force apart along that line. I mean, we can imagine a line over the surface, and per unit length, what is the total force? If F is the surface force and L is the total length of the object in which the surface film is in contact, or the liquid is in contact, then the surface tension can be easily given T as surface tension. We can call it as Ts also, will be force per unit length, F by L. Its unit definitely will be Newton per meter, or it can be dyne also. Now there is a mathematical expression for surface tension. Usually we symbolize surface tension by the symbol gamma. Practically, gamma has been found equal to half F by L. What is F by L? We have learned a little earlier. F is the force acting perpendicularly or tangentially over the surface having a length L. And y half, it is multiplied by half. Now what happens that a liquid is kept in a beaker or a container having two sides and also a base. Base fixes up the length and the sides also. So if the length is L and the total force acting upon it is represented by Fs, so the uh, surface tension will be equal to F by L. But not only this, if we consider the sides, this surface force Fs is divided into two parts. Certain force acting on side 1 and the other force acting on side 2. Yeah. This is the liquid level at the top of the surface, and these are the two sides. The distance between them is L, and the force acting is F by F. Now this force is divided equally on the two sides, and therefore we say it is F by 2 on both the sides. The reason for half is that the film has two sides, two surfaces, each of which contribute equally to the force. So the force contributed by a single side, gamma L, is equal to F by 2. The reason for half is that the film has two sides, each of which contributes equally to the force. So the force contributed by a single side, gamma L, is equal to F by 2. Or you can simplify it as gamma is equal to half F divided by L. Now something more about surface tension, very important and significant, is that surface tension is an intensive property. Intensive property basically depends upon the composition and the temperature of the liquid. Temperature, very important. Temperature is a dependent property of the surface liquid. Whenever surface tension is given, the temperature must be described, must be given. And then composition, of course, it depends upon the structure of the liquid. It may be alcohol, it may be water, it may be kerosene, or it may be anything. So the surface tension of ethanol or alcohol and the water would never be the same. Actually, the surface tension of alcohol, we write it as gamma ethanol, is not equal to gamma water. Why? Because they have different compositions, even at the same temperature also. Now, one thing is very important, and you must have noticed it also, that lighter objects like a paper, a piece of small paper, or even a blade, or even a lighter needle, which normally is non-wettable, lighter objects can float over the liquid. If you put a piece of water, a small piece of paper over the liquid, you won't find that it dips. It doesn't get in. It floats over the water. So the floating object should not be wettable. And actually what happens that there is a platform provided by the liquid at the top. And this platform is because of the surface tension. When you put a substance over here, light substance, of course it has certain weight, then because of the surface tension, it starts floating over it, but simultaneously there is a gravitational force acting. Now, the gravitational force within the liquid tends to uh, to, to dip the article placed over the substance. But there is a counterbalance. The buoyancy is maintained. Lighter objects can fold over the liquid surface, balancing the gravitational force. So this diagram simply represents the lighter objects floating over the gravity. Okay, thank you. And we shall be back again with something more about surface tension. Thank you. Welcome.